Good afternoon, everyone. I'm PCT Managing Editor Brad Harbison. I want to thank everyone for taking some time out of their day to participate in today's webinar, which is Fertility Control in Rats, presented by SenesTech, who are the manufacturers of ContraPest. And we know PCT's readers always enjoy learning about new technology, so I figure you really enjoy and get a lot out of today's presentation. So during the next hour, you will learn more about ContraPest, which is the liquid fertility control bait from SenesTech. And our presenter, Brandy Pyzyna, she's going to review the history of fertility control and wildlife management, and also talk a little bit about how fertility control can enhance integrated rodent management programs. As mentioned, we're happy to have Brandy Pyzyna as today's presenter, and Brandy has been with SenesTech since 2009 when she began working in Dr. Loretta Mayer's laboratory. And some of her past work has included applying the SenesTech technology in the rice fields of Laos, the subway system of New York City, municipal settings in Chicago, and a protein production farm in North Carolina. And Brandy has quickly risen through the ranks at SenesTech, and she currently serves as Vice President of Scientific Operations, where she leads the scientific operations and national account teams at SenesTech. And before we get started, just a couple notes to pass along here is this webinar is interactive, and we encourage everyone to ask their questions, and you can do so by typing them into the question box in the bottom right-hand corner of your screen. Any of those questions there will get sent to me, and I will compile them. And we are going to hold off on all those questions until the end of the webinar so that Brandy has enough time to get through her presentation. But again, we do encourage everyone to ask those questions throughout the webinar. And at this time, we're going to turn things over to Brandy. Brandy?
Thank you so much, Brad. I hope you can hear me okay.
Yes.
Wonderful, great. So thank you everyone for joining us today to talk about fertility control in rats. I know this is not a topic that is generally considered when you are thinking of rodent control. So I appreciate everybody taking some time to learn a little bit more. So today, before we talk about how fertility control can be implemented into your rodent control program, we're going to first talk about what causes animals to become pests. What problems do they cause, and ultimately, how do we control them? We'll then move into what is our options in terms of fertility control according to the literature. We'll talk about some of the pros and cons. And then we'll also then move into what problems rats cause us, what are their reproduction, why are they a good animal to use fertility control on, and then finally wrap it up with actually how to use fertility control in your program. Before I do all of that, I'm sure there's a lot of people who don't know who SenesTech is or what the company is. So I want to give you a quick brief history and introduction to SenesTech. We were founded by two scientists that are motivated to improve the lives of human and animals due to their deep love of animals. They have figured out a way to control animal populations through fertility control. And that is our core mission and why we have created a product to control rodents. Now, animals, we all love animals, but they do become pests over time. As humans move out of cities into the rural spaces, into the wide open, we are providing habitat, we're providing food, and the more we expand, we eliminate the predators. As we expand, we eliminate those predators, animals become then overpopulated. They live off of us. And the more those animals become overabundant as they're relying on our resources, there are causes of human-wildlife conflict. Whether it's native species or invasive species, they can adversely affect humans, and there's many things that occur. We can have property, habitat, and crop destruction. For anybody that lives in areas where there's deer or feral hogs, you know exactly how devastating these animals can be. Animals spread disease to both humans, livestock, your pets. There are numerous attacks on humans, and I think mostly of feral dogs when I think of attacks on humans. And you don't have to go very far to know that there are constant collisions with vehicle and aircraft when it comes to overabundant species. And more, there are extinctions or endangerment of seabirds or land birds due to cats and rats, which are causing a lot of problems in terms of ecology. Historically, the only choice we've had to control animals when they become pests are lethal approaches. And these can come in many forms. You can hunt the animals, trap them, poison them, electrocute them, and many, many others. And while all of these control methods work, there are downsides. And intended or not, there are potential injuries or deaths to non-target species. There's even deaths or injuries to humans. And with some of our lethal control methods, there are side effects to the environment. As we have progressed throughout the years, humans have become more concerned about welfare and the safety of lethal control methods, as well as what are the environmental impacts our lethal methods are having on the environment. Our concerns have translated into an increased amount of research into non-lethal control options. And as you can see from the graph on the right-hand side of the screen, research from the early 80s until the early 2000s has increased in terms of fertility control, whether it's models to test hypotheses, or you then translate that data into laboratory studies, or ultimately you're moving into the field and testing those different methods. When you look into the literature, there are three major types of non-lethal control approaches that we have tried to test to manage wildlife. You can translocate them to new areas, you can adopt them out, or you can control the reproduction. Reproductive control is broken into the literature into steroids and hypothalamic hormones. There's immunocontraceptive vaccines, and there's also contraceptives. As with lethal controls, there are downsides to the non-lethal control methods. When you look at moving an animal from one environment to another, there is an increased stress on those animals. There's also the potential that these animals could die in transit or once they arrive to their new location. And the costs associated with moving an animal from one area to another is very expensive and labor intensive. And there's also the potential to spread diseases and pathogens from one area to another. The horses that live in our city potentially have different diseases than horses that live in your city. So moving them causes some possible problems. And there's also adoption. Many people don't think of adopting overabundant species, but for those of us that live in the West, know there's always a call to adopt tortoises or feral horses and burros. And this can be very expensive, or there's a lot of rules and guidelines to go through. Not everybody can just adopt these animals. It's pretty difficult sometimes. Looking into reproductive control, there are downsides to these options as well. You can, for steroid and hypothalamic hormonal control, there is the possibility that these hormones are going to transfer into the food chain, or that there's going to be impacts to the environment. In terms of immunocontraceptive vaccines, this has been studied quite extensively in the literature, and there are some products that you have to dose the animals multiple times. This can be expensive and very labor intensive. And in some cases, there are site injection reactions. And when it comes to the use of contraceptives, there is the possibility that the products could affect the physiology or behavior of the target animals. With all of the disadvantages that the literature has told us, there are several advantages to using fertility control in wildlife management. There are models that are suggesting that contraceptives can be the most effective in slowing the evolution of treatment resistance or non-responsiveness. And what you can see on the graph on the right-hand side is that there are several cases of resistance in rat populations in the UK and the European Union. Those rats that are lethal are breeding and producing more rats that are resistant. So if we can potentially introduce a fertility control option, such as a contraceptive, we can slow the chances of those rats breeding their resistant genes. And there is advantages to fertility control in terms of the spread of diseases. When you introduce a fertility control into an animal, it actually removes all of the physiological costs of reproduction and lactation. It means the animal's not spending as much time breeding and lactating. So her physical condition's a little bit better. Her immune function's a little better. And therefore, she probably is not as susceptible to diseases as some of her breeding counterparts are. And when you think about lethal control, you are decreasing disease transmission. You're knocking the population down very quickly. However, there is the chance that you can disrupt the social organization. You're causing those animals to move into new environments. This is very similar to translocation. So again, you're going to force those animals to move into a new area to get away from your lethal control, which means you could potentially be increasing your disease transmission. And through the use of fertility control, you could potentially have a better chance of decreasing those diseases. When you look in the literature, there are two major types of species that have been researched upon. There are large animals that are considered K-selected species, and there are smaller species that are considered R-selected. And for those of you that don't understand R-selected and K-selected, that's okay. The larger animals don't reproduce very often. They maybe reproduce every couple years, and they have smaller litter sizes. When you look at the use of reproductive control in those animals, it's actually a little bit less efficient than the use of lethal controls. But if you're going to look at reproductive control in the smaller animals, the R-selected species, the ones that reproduce at an early age, they have a large litter size, but they don't survive very long, those animals are actually the best candidates for a reproductive control agent. And then when you dig more into the literature, you see that there are several studies that have shown that rats are a great candidate to use a fertility control agent on. In the 90s, there was a model produced that showed that if you can sterilize both sexes, you could actually gain control, at least 70% of control after 3 generations of rats being born. And that you see on the left-hand side on the black line. And when you contrast that with the red line that's on that graph, that's a lethal agent. So they've introduced a lethal agent into an environment. They've driven the population down, but quickly, in about 3 or 4 generations, the rats have reproduced back to their original population size. People have taken that idea and moved it into the field setting, and that's what you see on the right-hand side in the early 2000s. If you introduced a sterilant into only females in a rice enclosure, you actually decrease the population of rats and increase rice yield, which means you're not having as many juveniles in the environment, you're not having as much crop damage, you're actually having a better result for humans and animals. So again, there's been great strides in the literature that shows that rats are great candidates for reproductive control. And all of the literature put together, there are certain criteria that have been outlined for the perfect fertility control agent. Some of those include the active ingredients must be consumed in an oral bait. You can't vaccinate the animals. You can't go hunting them down and revaccinate them multiple times. The animals need to consume it. It shouldn't cause them any side effects. And the bait actually needs to occur, bait consumption needs to occur in the presence of other food sources. You want them to seek this product out. The bait must then be environmentally neutral in terms of secondary exposure to handlers and to the environment. And when possible, the bait production should be scalable and be fairly inexpensive. And when SenesTech looked at these criteria, we looked at the data in the literature and we looked at rats in general, we said, we can create that. Rats are in our selected species, they breed, they reproduce very quickly. We can take these criteria, we can make a product. And ultimately, driven by our motivation, we created ContraPest. So, what's the problem with rats? Most of us should know rats cause billions in dollars of damage worldwide. They eat our food pre-harvest, they contaminate our food post-harvest, or while it's stored in our storage facilities. They spread disease, both to us, to our pets, and to our livestock. Their gnawing causes infrastructure damage in every aspect of the world. Their digging, their burrowing causes a lot more infrastructure damage. And on islands where they have no natural predators, they are disrupting wildlife and ecosystems. They're a big source of bird decimation. So they're causing us problems left and right. And historically, we have used rodenticides or traps to knock their populations down. And while they work, it's only helping us for a short-term period. We're not eliminating 100% of that population most of the time. The animals that are not consuming our rodenticide, they're not going into our traps, they're breeding. And when you think about the fact that they're commensal animals, their reproduction is tied to the quantity and the quality of our food sources. So the more we knock them down, there's actually a better supply of food sources, a better supply of mates, a better supply of areas to burrow in. So their reproduction is actually going to increase. It's going to help bring them back to their original size. And there are cases where we have saturated islands with rodenticide and have killed all of the rodents, but we also have non-target species deaths associated with those. And when you look further into the literature, we have removed rats from islands, at least 100% of them, but within 4 to 5 months, their populations have recovered. So what are we doing wrong? We need to figure out a way to work with the ecology of the rats. They are commensal species. Again, their habitat, their density depends on us. The more harborage we provide them, the more spaces we give them to eat, the more they're going to reproduce. But we also need to work with their behavior and their physiology. Rats, for those of us that don't know, need to consume 10% of their body weight a day in liquid. They're also neophobic. You can't simply put a new bait station or new bait into their environment and have them consume it usually in 24 hours. They're going to investigate that station. They're going to take some time to enter it, to feel comfortable in it. Then they're going to take even longer to consume that product that you put in it. They're smart. They have figured out what we do and how we do it, and they're constantly outsmarting us. And then when you look at their home ranges, they're very defined and they're overlapping, which means that they don't go a mile up the street to go get food. They're going to go within their home range to find their food, to find their mates. And along that route, they're going to know exactly where they can hide from predators. They're going to know exactly where they can burrow. And within these home ranges, they will compete for resources. So they're territorial. They're going to fight for food. They're going to fight for their burrows. They're going to fight for mates. And then, again, these rats are selected. They are small, they live for short periods of time, and they reproduce very quickly. And this is why rats in particular are a great candidate for using fertility control agent. When you think of the rat reproduction rate, under ideal conditions, 2 rats are responsible for 15,000 descendants. And that's not including any deaths. That's not including any rodenticide or snap traps. But when you factor those criteria in, 2 rats are still responsible for thousands of descendants a year. And that is why it's difficult to maintain control of the rat populations. So we need a better way to control them. So because this is a webinar, I was unable to provide an animation here. So I have 13 slides or so to show you what happens when you introduce fertility control into your rat management program. And to show you what happens after a year, we had to make some assumptions. So first, the average lifespan of rats in our model here is 6 months. In normal circumstances, maybe they last a year, somewhere between 6 months and a year. We have stated 6 months. The ability to reproduce for both sexes is 2 months old. Females produce at around 30 days. Males, it's about 45 days, depending on the species. But we made them both reproduce at 2 months here. Every litter consists of only 8 pups. And when you look at, again, the average, depending on the species, it can be anywhere from 6 pups to 12 pups. We met somewhere in the middle. And then the vast majority of our population is consuming a contraceptive agent. We've not introduced death, predators, or any sort of other lethal controls. So let's look at what happens. A couple other things before I flip through these slides. All black rats on this slide are fertile. They have not consumed a contraceptive agent. And green rats have consumed a contraceptive agent. They are considered infertile. So your population started with 2 rats. You saw them, so you decide to deploy a contraceptive agent. However, at month 3, the female reproduces because she was already pregnant, which brought your population from 2 to 10. One of the founder rats decided to consume your contraceptive agent, but nothing happened yet. That's okay. Once the pups, the juveniles here, have left the home comforts of the burrow and have decided to explore on their own, they found the contraceptive agent, and most of them have begun to consume it. However, there's still a couple that are not consuming the product, so you get another generation, which brought our population up to 18. Finally, when the second generation of rats has left the burrow, the majority of them begin to consume the contraceptive. But unfortunately, a couple of them met up. They started breeding. Our population has now gone to 24. Our founders have died now. So our population now consists of the first generation, which are now our alpha, older rats. We have a second generation that's a little bit younger. We have a third generation that's pretty juvenile still. Finally, as the rats begin to leave the burrow, they begin to explore. The majority of them find the contraceptive and they begin to consume. And slowly over time, you're not seeing any new juvenile rats in the environment because there's no rat to leave the burrows. They have not been born, so you're only seeing the adults running around. And slowly over time, you're actually going to start seeing your population decrease because the older adults are finally dying off of natural age. And by the end of 12 months, if everything is right, you should have a very small population of rats. Again, this is an ideal situation, no death. So if we had incorporated a lethal technique of some sort, our populations would have been driven down quicker. So in terms of the use of a fertility control agent, setting expectations is a little different. You have to think of not just the situation you're baiting in, but you have to think about the rat. You're not going to just put this product out and have it work in 24 hours. You're not going to see those results that quickly. The first thing that needs to be considered is the fact that, again, rats are very neophobic. They are not potentially not going to enter your bait station or consume a new product right away. So if you can use a non-lethal tool or a product that is considered a control that doesn't have any active ingredients, you could put that out and allow rats to acclimate to the new stations. You can also give them time to try that liquid or try that product. And then if you can do this, if you or your client allows, you can make sure that your stations are placed in the best location and that you have a lot of uptake, which is why then you also need to think about the importance of station placement. If rats are not consuming a rodenticide, if they're not consuming a fertility control agent, it's not going to be effective. So putting these stations out, it's not about how many, it's about where. You want to make sure that those rats are comfortable foraging in the location these stations are placed. It's a very strategic process. But then when you're thinking about where you're putting these stations, you also have to think about the scope of the problem or your treatment area. Rats have this home range. You don't want to only get to a small proportion of your population. You want the biggest proportion of the population to consume your fertility control, your contraceptive. Just like a rodenticide, if one rat consumes a rodenticide or one rat gets caught in a snap trap, it's not going to be effective in terms of rodent control. It's the same thing with fertility control. You need them to consume it. So you really need to think about how and where to place these stations, not a number. And then when it comes to seeing the results, the time is going to vary. Are you putting your contraceptive agent out as a standalone product, like we did in our model? If you do, it could take some time. You're not bringing in any death. You're only allowing these animals to die naturally. So it could be up to 6 months before you start seeing less juveniles in the environment and you start seeing that decrease in your population. But if you can combine a fertility control agent with another integrated tool, you're going to see results even quicker. You can introduce fertility control first and get all the rats onto the product, let them feel comfortable, and then introduce your lethal. Or you can swap that and you can introduce the lethal control quickly, drive that population down, and then keep any survivors from reproducing. But if we do that, there is the chance that they could become beta-verse, and they're not going to enter your fertility control station. So you really have to think about how to use this and where to use this. But ultimately, when you incorporate a fertility control product into your integrated pest management plan, you're going to see results even quicker.
Thanks to everyone for tuning in to today's webinar. If you have any questions about what was presented, or if you have any additional questions about ContraPest, contact SenesTech at 928-482-7312 or email technical.services@senestech.com. You can also learn more at www.senestech.com/ContraPest.